host, Jacen Starkey, with Story System from the Literacy Coalition. Here's my mom once again.
Hi!
And today we will be blowing up a balloon, but not as usual like we did last time. This time we will be using baking soda and vinegar to make a chemical reaction.
That's right, we're doing Chemistry 101, and some people use baking soda and vinegar to make a volcano, but we're actually going to use it to do work. And what you need today is 1 cup of vinegar, you need 1 balloon, a funnel, and 1/3 cup of baking soda.
Yep, right there.
So, and I forgot to put it on my list, but you also need a plastic bottle.
Yep, right here.
So, the first thing you're going to do for this particular experiment is we're going to be mixing 2 different substances, and it's going to cause a reaction. Those 2 substances are going to work together to do something.
And those 2 substances are vinegar and baking soda, like we said. Now,
That's
Mom's
right.
going to stretch the balloon out to, make it more flexible, while I am going to open the vinegar bottle and pour the vinegar in that.
You just need 1 cup, so take a look at the side and stop when you get to this 1 cup, okay?
All right.
A great book to think about if you're thinking about balloons and chemical reactions is What Was the Hindenburg? This is one of the Janet Pascal series, and what's really cool is the story of the Hindenburg. It's an airship that could carry a lot of people, but they didn't fill it up with carbon dioxide, which is the gas we're going to create with our experiment today.
Yes.
Instead, it was filled with hydrogen, and hydrogen is very, very, very flammable. We are not doing anything flammable today.
Yeah, flammable stuff should be used at home.
So, what you want to do is you want to take your balloon and put it on the end of the funnel.
And then I got my baking soda, and I'm supposed to get this.
Go ahead and set it down.
Okay.
The reason is, if you dump all the baking soda into the balloon at once, it's going to get stuck.
Yeah.
The air that's trapped inside the balloon already has to get out of the way in order to let the baking soda come down.
And so if it won't go down, you can take a pencil and stick it down the middle of the funnel.
You should be able to see a little hole whenever you're trying to fill it up. So,
now, after that scoop, let's tap it. Oh, there's big pieces in there. I'm going to need to destroy those.
so he's going to make some room here. This is one of the parts that takes the longest, is actually putting some of this in your balloon.
Yeah, that's the part that always takes the longest to do.
Now, we've actually blown up a balloon before. We tried it earlier. Jason's going to show you the balloon that we filled up.
Here it is. And if you're wondering why it's leaning down, that's because some of the baking soda is actually still in it. If you put your hand on the spot where it is, it actually feels cold.
That's because chemical reactions involve exchange of energy. And sometimes that energy exchange is going to either release energy in the form of heat, and we call that exothermic.
Yeah.
Or it's going to absorb energy, meaning it gets colder.
Now, we're using this whole cup of baking soda, right?
We're using 1/3 a cup of baking soda.
Luckily, this is
It just takes a little bit of time, I know. But that's why we use our little scooper and kind of put it on the side. Yep.
Don't you just hate it when there's a big chunk and you have to destroy it?
I know, craziness, right? And then you just shake your balloon, you shake your funnel.
Yep.
And that'll give us some space. Like I said, you want to make sure that you are letting air get out so that your baking soda can get in. This was the longest part of our experiment, was actually getting that to work. Now, this reaction, did it make heat when we did it earlier, Jacen?
It did not make heat, actually.
No. So was it an endothermic reaction or an exothermic reaction?
Endo.
Right.
Because it was cold.
Can you think of anything else that has to do with endo or exo that you've learned in science?
Well, I'm trying to think back to our other videos. Go watch them, by the way. Some of the other videos that we've done, I think one of the ones was, I'm trying to think where one would produce heat.
I'm actually thinking of something you've done in science class with skeletons. Endoskeletons and exoskeletons. Endo means your skeleton is on the inside.
And exoskeleton is like where a bug has like their own plate. not really a skeleton.
Right. So exo means outside. Endo means inside.
All right, wait. Let me feel the balloon to see if we have enough yet.
Yeah,
I
pretty
think
good?
just this last, and then we'll be good.
Excellent.
Now, the reason why we're putting the pencil in the middle is because, well,
We're just giving ourselves room. So we've got about this much baking soda in it right now.
that's good.
Now I'm going to make sure that I take a tissue, and you can either wash your funnel out or you can just wipe it out. And now we're going to take our empty water bottle.
Here it is. Then we need the funnel.
Funnel on top, and Jason's going to gently pour the vinegar inside because I don't really want vinegar splashed all over me.
Yeah, that would stink.
Yeah.
And also,
Literally.
Yeah, literally,
Yeah,
it
that
would
would
stink.
stink. That would
Now,
stink.
also, the reason why you want to clean out the funnel after you filled up the balloon with baking soda is because you don't want the chemical the reaction to start out, well, too early.
Yeah, before you're ready.
Yeah.
All right, so
All right,
now
I
we can
think-
set these two items to the side.
Yep, we don't need them anymore.
Now, the next important part, and Jason and I are going to work as a team. I'm going to
Yes.
hold the bottle, and he's going to take care of the balloon part. But what you're going to do is take the top of the balloon, and you're going to stretch it over the top of the bottle.
Now, as soon as we flip this balloon up, it's going to change everything.
You are going to see your reaction start to happen.
Now, I hope you guys get amazed back at home, but
Hope so. See what happens.
I've done this before. We're going to say it again.
All right. So you squeeze it so all the baking soda comes out.
Starting to look like an avocado.
So that
Whoa.
sound you hear
Whoa.
is the sound of carbon dioxide gas being created by the chemical
Whoa.
reaction. The chemical reaction of the baking soda
Oh, that's a gross sound.
of the baking
It
soda.
sounds like when I click my tongue, but worse.
All right, so we can actually see bubbles inside the balloon right now.
Yeah, and if you see the bubbles, that means the chemical reaction is still in progress.
Right, now when the chemical reaction is over, all the crazy bubbles pretty much stop. So we're gonna shake our balloon to get the rest of that baking soda out. All right, we do have a balloon. It is blown up. It's hard to do with our lungs, but we were able to do it with science. Now I'm gonna pinch off the top and pull this off gently so that I can tie the end of the balloon.
Yep.
And that way we now have a balloon that we can play with.
Yep.
This one actually doesn't have, we did an even better reaction the second time than we did the first time.
Yeah, because this one, actually, look at this.
Right?
And it flies, but this one,
Yeah,
see?
that was still has some baking soda inside.
Yeah.
So thank you so much for watching.
This program was brought to you by the Children's Service Council of Palm Beach County, Primetime, and Literacy Coalition's Stories in STEM.
Bye.
And we'll see you next time on the next Stories in STEM. Cut.
Nicely done.